All right, so we just learned that this is called the rational exponent, right? Where it's in fraction. And I can change it to a radical exponent or radical format. And how would I write that in radical format? The nth root, yeah. So the nth root of a to the power of m, right? Or I can write it as the nth root of a all to the power of m. So either way, okay? So the condition is m has to be an integer. Integer means a whole number. N is a integer greater than 0. N can be any number as long as it's a whole number. A has to be greater than or equal to 0. So it has to be positive for if n is even. Okay? The reason for that last one, because look at this. If n is even, so if I have the square root of a number, okay? Can I have your attention here for a second? If I have the square root of -4, when you do that on the calculator, what do you get? Yes, and it will keep saying math error.
Mine says 2i.
2 pi?
2i.
When you did the square root of -4? You know why? Because it's an imaginary number. But let me just put it in a mode. And then now I put it in the right mode. You had it in the complex mode. Okay? So this is going to give you an error because it's not a real number. It's an imaginary number. Okay? Now, eyes on me for a second. How about if I have the 4th root of -25? Can you tell me what you're going to get? An error as well, no? Anytime you do an even root of a negative number, you are going to get an error. That's why a has to be positive. A has to be positive if n is even. Okay? So remember this terminology. Radical means the root. They start with the, well, radicals means the root. Rational means fraction. So let's write these as a rational exponent. Square root of 25. How can I write it as a rational exponent? 25. What would be my power though? What's that? 2, right? So that's going to be 25 to the power of 1/2. How about the second one? -125 bracket to the power of what? It's 1/3, guys. Because this is in the root, it's going to be 1/3. Remember this. Remember this rule? If I have a to the power of 1/m, it's the same thing as the mth root of a, right? So if I have a root, that is going to go in the denominator. Okay? How about this one? So 1.05. 3 over 4, that's right. So to the power of 3 over 4. Why 3 over 4? So the 4 is going to go in the denominator, right? Because that's your root. And then the 3, which is the power of 3, is going to go in your numerator. Okay? How about going from rational to radical? How would you write that in radical form?
Oh, yeah.
What is it?
81 is the square root.
So square root of 81, yeah? I don't have to put that 2. That's the only thing that I don't have to put. You don't have to put that 2 because if you don't put it, that's the norm. The norm is the square root. Okay? How about this one? How would I write that one?
Negative 64 with the 3 outside square root.
So cube root of negative 64, yeah? Perfect. How about this one? 32 to the power of 4 over 5.
32 is square root.
So what would I put in the root? What root is it? The 5th root of 32 to the power of 4. Yeah. Okay. So I'm changing between radical and rational. Radical exponent, rational exponent. Okay, you need to practice this. Make sure you practice and make sure you know how to do it. Okay? Now, when I'm asked to solve, I have to do opposite operation. Remember that. Okay? I have x to the power of 4 equals 16. How can you solve for x? So the root of what? The root of 4. Because the opposite of, okay, let's go back here. What's the opposite operation of square? Opposite operation of square is square root. Opposite operation of cube is cube root. Opposite operation of x to the power of 4? The 4th root. Okay? So these are your the opposite operation. Okay? So if I want to get rid of that to the power of 4, I have to either, I can write this as well. I can do this, right? Because the 4th root, or 1 over 4, is the same thing. Remember that? If I go back here, right? The 1 over 3 and the cube root, they're the same thing, right? So if I want to, I can raise it to the power, I can do this to both sides. Or what we used to do the 4th root of x4 and the 4th root of 16. Does it make any difference? Are these two any different from each other? Are these two lines any different from each other? No, they're the same thing. They're just written in different format. You pick what format you want to use. Okay? What format do you guys want me to use on the board? The root format or the exponent format? The root format? Okay. So, to get rid of the 4, I'm going to take the 4th root of both sides, right? The 4th root and the power of 4, they're going to cancel each other. So I'm going to be left with, what's the square root of the 4th root of 16? 2? write this in a radical format because we are used to the radical format. We've seen it before. Okay? If I want to write this in a radical format, how would you write it? Square root of x power of 3. Okay? So I just rewrote this in the radical format. That's all what I did. I didn't do much. I haven't isolated yet. I'm just going to make it small, okay? Now, we want to isolate for x. What do I need to get rid of first? What do you want to get rid of first? The 3, the cube, right? How do you get rid of a cube? What's the opposite of cube? Cube root. So the first thing that you want to do, you want to cube root both sides. Yes? So when I cube root both sides, I'm going to get rid of the cube. And I'll be left to square root of x equals to, what's the cube root of negative 27? Negative 3? Now, I have square root of x equals to negative 3. I want to find what x is. What do I do to find what x is? What's the opposite of square root? No? Opposite of square is? What's the opposite of square? Square root. What's the opposite of square root? Square. Right? So if I want to get rid of the square root, I have to square it. Right? So let's square. So that gets rid of the square root, and that leaves me with x equals 9.
How'd you get the first one?
How do I get which one? The first?
The first what? 8.
This one? Like when I wrote it as
No, I mean.
this one?
Yeah.
I did the 4th root of 16. You're not getting that?
I don't know how to put it in the top. Like, how do you put the 4 outside the square root?
So you do the shift this button, and then you put 4, and then you bring it.
Oh, do that again. I'm sorry.
You see this button here, right? That's what you're looking for. So you have to do shift this, and gives you this format. Here you're going to put 4, and then you're going to bring your cursor inside, and then you're going to do 16. Okay? We're good with that? So can I just want you to look here for a second, okay? So the steps that I followed, okay? So first, so I had x 3 over 2, right? The first thing I did is I raised it to the power of, to the cube root. So first thing I did is a cube root, right? And the second thing I did was a square, right? Eyes on me, please, eyes on me. I don't want you to write anything right now, okay? So the first, to get rid of that 3 over 2, first thing I did is I cube rooted. The second thing I did is I squared, okay? If I have a cube root, pretend this is not here. If I have cube root to the power of 2, how would I write that in rational format?
Like, 2 over 3? Or 3?
2 over 3, you're right. 2 over 3. So I'm going to write this, that's my base, to the power of 2 over 3. Right? Yeah? What do you notice about the 2 powers? Yeah, they're the reciprocal of each other. Because what happens, okay, look here why. Because power to the power, what do I do with them? Power to the power, I multiply, right? So 3 over 2 times 2 over 3, okay? That's 6 over 6, no? 3 times 2 is 6. 3 times 2 is 6. What's 6 over 6? 6 over 6 is 1. Did I isolate for my x? Is it x by itself now? It is. And that's my whole point. My whole point, when I'm solving for a variable, I want it by itself. Okay? So if I have it to the power of 3 over 2, to get rid of that power in one step, I can just raise it to the power of the reciprocal. Right? Guys, you need to see this. You need to see this. Look, I know I'm moving between different things, but if you don't understand the basics of it, you're not going to understand the more complicated questions that we're going to get. This is not complicated compared to what's happening next. Okay?
Can I just copy that down real quick?
I will give you time to copy this. I just want you to pay attention to this. So don't copy anything, just pay attention to me. What's the opposite of square again? I'm going to ask you this again. What's the opposite of square? Square root. How do I write square root as a rational, as a fraction? What is square root as a fraction? So if I don't want to write it as a square root, what can I write it as? Power of what? 1 over 2, guys. 1 over 2. Square root is the same thing as 1 over 2. Right? So the opposite of square is square root. Or, in other words, the opposite of square is the power of half. 2 and a half, they're reciprocal of each other. Right? And this is what's happening here. This is what's happening here. The power of 3 over 2, the reciprocal of it is 2 over 3. Right?
Yeah, sorry.
So if you don't get the basic, which is the square, you're not going to get the more complicated ones. Okay? I will give you time to copy this. So, speaking of which, if I have this, how can I isolate for x?
Cube root.
So, if you want to do it the longer way, so write it as a cube root of x squared. Okay, so I wrote it as a radical form. Square root first to get rid of the square. Okay, I'm square rooting first. So that gets rid of the square. What's square root of 64? Then
you
cube it.
Yeah.
Cube it. Because it's already cube rooted, you need to cube it. And what would your answer be?
2.
No,
What?
no, it's 8 to the power of 3. 8 to the power of 3. 2 8 to the power of 3. You're cubing, not cube rooting. 512? Is that what you got?
Yeah.
Why did we put a 3 outside of the brackets?
Right here?
No, yeah, right there.
Because I want to get rid of the cube root, and to get rid of the cube root, you need to cube.
Okay.
Opposite operation. Opposite operation. Opposite operation. Now let's see if I'm going to get the same answer if I do it the simpler way. Okay? So, my question is x 2 over 3 equals 64. So, the easier way says I have to raise it to the power of, what would I raise it to the power of? What's the reciprocal of 2 over 3? 3 over 2. So on the calculator, can you do 64 to the power of 3 over 2? What did we get? Right? So what happened here, the 2 over 3 and the 3 over 3 cancel each other, right? All right. So I'm gonna give you time to digest this, okay? And then what I want you to do is I want you to, so copy whatever you need to copy, but then when you're done, I want you to think about the next question, and I'm just gonna tell you what each letter represents. And I want you to put it into the formula and try to solve. You're solving for I. Okay? I want you to try this question. Might be hard, we'll take it up. Okay? And then if you want to copy, here are the notes.